Hi and welcome back. In this lecture, we can talk about Key Insight 1, Digital Transformation of the Water Management Industry. Well, digital transformation is the incorporation of technology to components, business processes in the water management industry to gain a much more better understanding of the efficiency, productivity, utilization of resources, and also wastage in real time. So there are quite a few number of components that we're going to talk about, and also we're going to talk about these components in much more greater detail in our section, the impact of Industry 4.0 on the water management industry. Well, if you look at the digital transformation of the water management industry, we have something called Advanced Metering Infrastructure, or what we call AMI. So in very simple terms, AMI is able to send the water consumption in real time to the water utility provider. So many water providers have started to realize the value of measuring consumption of water just beyond billing. So many water providers all around the world fix water meters at the consumers or business locations to understand how many units of water that the consumer or the business has consumed. But over time, we have come to realize the fact that we need more data about the consumption patterns. So by knowing these consumption patterns, we can understand things like wastage, improve the process efficiencies, and also understand things like peak days and peak times of water consumption. So this will help both customers and businesses to make better, predictive, and proactive decisions. So there's something called big data analytics, which is basically taking data from multiple sources to get a much more holistic and a 360-degree view of business processes. So for example, when you use big data analytics tools on water consumption, we can understand everything from sourcing to pumping to consumption to wastage on one single view. So big data analytics tools are also the key to enable these infrastructure solutions to reach its full potential. Also, the aim is to offer value-added services to both internally to the business and also to the customers to make the water management processes more efficient. For example, these systems are able to predict the demand and also to detect leaks as well. So what are the benefits of having these advanced metering infrastructure platforms? The main thing is to increase the operational efficiency. So connecting advanced metering infrastructure with other sources like SCADA, which is basically supervisory control and data acquisition systems. So these are basic systems of software and hardware elements that allows industrial organizations to control processors locally or at remote locations, monitor and gather as well as process real-time data. So a lot of water utility companies are using these systems to monitor and control the plants and other infrastructure. Then we have things like CMMS, which stands for Computerized Maintenance Management System. So these are also maintenance systems used by water utility providers. Then we have ERP, which is Enterprise Resource Planning. So a lot of companies use this for managing the entire business processes end to end. Then there's GIS, or Geographic Information Systems. So this is basically combining geographical data and geographical science to assist other industries like the water management industry. Then we have Internet of Things sensors. So IoT is basically used for capturing and reporting real-time telemetric data like the temperature, ambient noise, sound levels, vibration, humidity, and other similar factors. So by connecting AMI with these kind of sensors and devices will enable companies to optimize their business processes, helps to reduce OPEX or operational expenditure, and also integration with what we call digital twin. So digital twin is basically a digital representation of a physical entity. So we'll talk more about digital twins in a few minutes. Then more sustainable use of resources. So AMI will reduce the volume of unbilled water in networks by conducting periodic water balances. For example, how many water units have been pumped from a distribution network, and within that distribution network, how many water units have been consumed. So then we can have a good balance of how many water units have been leaked from the system. Then this will also improve the efficiency of the system by detecting fraud and leaks at an earlier stage, alert the customers of any potential leaks, reducing energy consumption because we do not need to run pumps every single time. So if we can understand the supply and demand, then we can adjust the pumping schedule accordingly as well. And also we can significantly reduce the environmental impact. Then we have things like better value-added services for customers. So things like real-time alerts and notifications of the water consumption, water leaks. Consumers can put like a threshold or sort of a limit in their app, and when the limit is approaching, it can notify. So this is very similar to the cellular data limits that we set on our smartphones. So when a certain capacity is reaching, it will alert you saying this is reaching and to be careful. Then we can understand consumption in real time to make better and informed decisions. Then we come to digital twins. So this is basically a digital representation of a physical entity. These systems require a large amount of data from physical entities from multiple sensors to map the physical entity to the digital entity in real time. And also it helps to make better decisions as they provide a holistic view of the system. And the best part is you can run simulations of the real and fictional scenarios on the digital twin to see how the system would behave and respond to both internal and external environmental changes. And also in digital twin, both physical and dynamic aspects must be represented. For example, if there's a moving component in the physical component, that component must be moving also in the digital twin. And if the RPM or the revolutions per minute changes dynamically, it must also be represented in real time on the digital twin as well. So what are the benefits of digital twins? The main thing is increased resilience because these digital twins have something called artificial intelligence, which is basically giving the computers to mimic human intelligence and understanding and to make decisions on their own. So digital twins are able to adapt quickly and safely as they are supported by artificial intelligence, and also they are able to test out scenarios before applying them into the real world physical entity. And then it can also anticipate problems and identify the measures need to prevent these emergencies and minimize the consequences and the negative impact that it might have on the business continuity and operations. Then increase efficiency. So digital twins help us to make decisions based on their impact on different processes within the system. For example, optimizing the energy consumption by determining the best pumping schedules, energy efficiency by more efficient asset operation and systems planning. So those things can be done using digital twins. So talking a bit more about the benefits, you can also combine all these things to deliver a better and a great customer experience. So digital twins can help to adjust the water supply based on the real-time demands from the customers, including critical users like hospitals, and ensure that the supply is there at all times. And also it can provide users with high levels of detail about their water consumption patterns, leading to a much more better awareness and responsible use of water. Then increase sustainability and reduce carbon emissions. So urban water systems could be safely and efficiently operated with reduced energy and consumption. And also this will facilitate two-way communication. So from the device to the water supplier and from the water supplier back to the device. Then we have things like intelligent asset management. So basically embedding digital technologies to assets to extend the lifetime. For example, automated CMMS. So these automated computerized and maintenance management systems will be able to anticipate replacement, adjust the maintenance tasks and prevent outages, and also more efficient asset management equals significant economic and environmental benefits. For example, if we can extend the lifespan of the asset or fully utilize the asset to its lifetime or life extent, we can save a lot of money. And also, if we can reduce the number of repairs, that too will reduce our operational expenditure as well. Then there are environmental benefits like reduced carbon emissions, and also it will optimize the productivity as well. And it ensures increased service availability and reduces disruptions and downtimes. And it's estimated that these smart systems are able to reduce the energy used by mechanical equipment by up to 5 to 10%. So if you look at the time that these equipments run, it's almost like 24/7. So if you look at 5 to 10% savings with the amount of electricity that's being saved, it's a massive saving. Then we have things like geographical information systems or GIS. So integrating geographical information systems with the water management industry will further improve the efficiency and the effectiveness, also give better insights to solve problems, to increase the sustainability, and also enable to create topologies with different hydraulic elements like valves, nodes, filters, and plugs. So for example, if you want to pump water to a mountainous region, it will help you to understand the volume of water to be carried by each pipe according to its diameter and nodes. And if you look at the applications of geographical information systems on, for example, drinking water, it can help to minimize the water service disruptions, identify and alert consumers, intelligently guide inspections, for example, if you're using autonomous robots, and also you can use these systems to relay the real-time geolocation of the field work and things like that. Then if you look at wastewater, it can help you to understand wastewater-based epidemiology. So for example, during this whole COVID-19 pandemic, COVID-19 virus concentrations were recorded from wastewater collection plants to understand the level of COVID-19 patients in a certain population or area, to identify the concentration of the SARS-CoV-2, which is the virus that's causing the COVID-19 disease. And finally, if you look at irrigation, you can do powerful visualizations of the volume of water at each location in real time, and also prioritize assets which needs to be replaced and things like that. Well, that's about it for Key Insight 1, Digital Transformation of the Water Management Industry. I'll see you on another lecture.